Today we're sitting down to talk about EVM storage. And the reason I'm going through this is because last year I drew a diagram that got some traction and I never explained it. So this is my attempt at going through that diagram, but also giving you a higher level introduction to like why this matters. EVM storage comes into play when you're writing smart contracts on Ethereum, right? So Ethereum allows you to write programs and these programs execute code. And as part of executing code, there is some storage attached to each contract. Now, to run any program, you need to be able to read and write memory. On Ethereum, when you read and write memory, it costs gas. EVM storage is essentially a way for smart contracts to write some data and read some data at a very high level. Let's jump to the top of the diagram here. We have this kind of idea of a database, and this database, you can think of it as being attached or plugged into the smart contract. And the smart contract has access to 2 to the power of 256 storage slots. Now, these storage slots, each of them stores 32 bytes. 32 bytes is 256 bits. So you have data like a uint 256 that would be stored in one storage slot, which in this case could be slot 0. And so we've talked about slot 0 here, but in reality, there's so many more slots, and you're actually going to be broke if you try to fill up all these slots. It's also useful to think of this entire data structure as a key value store. In order to access one piece of data, you'll have to know the slot, and when you access it with a slot number, you'll be able to get back the value at that slot. Then conceptually, this data grows and shrinks over time, but in most cases it grows. So a lot of smart contracts do these write operations to the EVM storage, and they're effectively just filling up 32 bytes at a time. In some cases, you can zero out a slot, or you can self-destruct the contract. And in these cases, you actually get a gas refund. So the amount of gas that you paid to execute that transaction will be reduced because you're getting a gas refund. And the reason you get that gas refund is because you're freeing up space on the blockchain. So every node on the network actually has to store all of this data. When you zero out a storage slot, it's an altruistic action, so the network rewards you for that. Going down to the bottom here, you can see that we have this smart contract, and at a high level, what I want to point out is that the ordering of global state variables, each one of these is a global state variable. The ordering of these global state variables matters because if, let's say, in the future you had a smart contract that was upgradable, so it had this proxy pattern set up, if you deploy a new implementation that has these state variables in a different order, it will actually continue to read the same storage on the proxy. And that storage order is immutable. So if you had an owner address at slot 0, and then on the new contract, you had an integer at slot 0, well, when the new contract tries to read slot 0, it's actually still going to read the owner address instead of the integer. And that matters, and it's introduced bugs in a whole load of protocols. So be mindful of the ordering of your smart contract variables. On this side of the diagram, we can see how each variable type is stored in the EVM memory. We can get into a lot of the low-level EVM details here, but from a high level, it's pretty straightforward. So Solidity has kind of two broad data types. It has value types and it has reference types. Value types are pretty straightforward to understand. Let's take a simple value type here of uint256, and that's stored at slot A. So we know that 256 bits equates to 32 bytes, and that's going to all get stored in slot A. Then we have a fixed size array of size 2, and we know that that's 64 bytes. So that's actually going to take up 2 memory spaces. And you can play this out for each of the different data types going down the contract. You'll find that some data types store the data directly in the continuous memory, and then some actually give you a reference to the data somewhere in the massive key value store. Okay, so that's been EVM storage from a pretty high level. You should have learned that EVM storage is associated with every smart contract. The amount of storage available to each smart contract is huge. To actually fill up that storage would be infeasible because it would cost too much money. Storage can be deleted and you'll get a gas refund. Having a solid grasp of EVM storage is going to help you on your smart contract engineering journey. So thanks for watching and hope you enjoyed.